So, right, good morning. So, let's just quickly go through the analytical geometry that we've done in grade 11 and grade 10, right? Because when you look at your paper 2, usually question 1 and 2 is stats. Question 3, it's usually analytical geometry that I can give to a grade 11 learner, and they can actually get it right. Okay, so just a few things that you need to remember from grade 11 is the distance between 2 points. This formula here, actually, it is given in your exam paper at the end. Okay, the midpoint, that's the formula for the midpoint. That's the formula for the gradient. Okay, yeah, this sounds simple, but it's very important, right? You must know that if two lines are parallel, the gradients are the same, right? And if two lines are perpendicular, the product of the gradients is equal to -1. So that means m1 times m2 should give you -1 to show that they are perpendicular. Collinear points, these are points that are in the same straight line. So if I have this point, let me call it A, let me call that point B, let me call that point C, and they're all in a straight line like that, then they're collinear. So which means that the gradient is going to be the same because it's the same line, right? So the angle of inclination, right? So remember you have to find your gradient first. So the tan of the angle of inclination is your gradient. So when you want to find the angle, you're just going to find the tan inverse on your calculator, right? And the equation of a straight line, well, y equal to mx plus c, m is your gradient, c is your y-intercept. Or you can use that formula instead if you have to find the equation of a straight line. You will need to know that. And, okay, a line parallel to the y-axis or perpendicular to the x-axis, so x equal to k. So the gradient of a vertical line is undefined. It's not even possible to find it. And the gradient of a horizontal line is 0. Okay, those are the things that you still need to remember for analytical geometry. Now, let's just quickly go through that example there because that's a grade 11 kind of question. That example that we have on page 2 there. Alright, so in the diagram alongside, which is this diagram here, there is the points A, 3, 5, B, -4, -1, C, -1, and -6 are 3 points in the Cartesian plane. First question there, that one. Calculate the coordinates of M, the midpoint of AC. Okay, let's look at our diagram. Which one is AC? Here's the line AC, right? A is the coordinate, C is the coordinate over there. So what you need to find is the midpoint, right? We learned about the midpoint formula. This one here. So the midpoint formula, we learned about this, right? In grade 11, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. It doesn't really matter which one is x1 and y1 and which one is x2 and y2. But if this is x1, then that obviously is y1. And if this is x2, that's obviously y2. And you can do it vice versa, it doesn't matter really. But x1 and y1 must go together. That is very important. Okay, so let's calculate that. Okay, so x1, which one is x1? It's 3 here, right? Okay, I've taken that one. So it's 3 plus, okay, which one is x2? -1. Okay, so that's -1 over 2. Then, which one is y2? That's 5 there. Remember, they should go together. So 5 plus, which one is y1? This one is -6 over there. So it's -6 and divided by 2. Okay, let's calculate that. So 3 minus 1, that's obviously 2. So over 2. And then 5 minus 6, that's -1. So -1 over 2. Okay, and our midpoint now, 2 divided by 2 is 1, and then this is -1/2. So that is the midpoint. That's the answer to 1.1. Okay. Alright, so what's the next question? Gradient of BC. Okay, so determine the gradient of BC. Alright, so there is the gradient formula, m equal to change in y, so y2 minus y1 over change in x, which is x2 minus x1. Okay, what's the gradient of BC? Let's see, which one is the line BC? This is the line BC. Alright, so remember y2 can start anyway. I'm just going to start there. So y2 is negative 1 minus y1, which is negative 6 over x2 is negative 4 minus x1, which is negative 1. Okay, so this is going to be equal to negative 1, obviously plus 6 now, which is what? 5, right? Okay, 5 over negative 4 plus 1, so that becomes negative 3. So which means, yeah, you can just type it in the calculator one time anyway and get the answer, no problem. So this means this gradient is negative 5 over 3.
So is the equation that MC equals something, I don't know.
Which one, the equation of a straight line?
1.3, so they asked me to find the equation of the line parallel to BC.
Yes, we're going to use that, definitely. Determine the equation of the line parallel to BC passing through M. Line parallel to BC passing through M. Oh, remember we calculated M, right?
So
what coordinates did you get, by the way?
Midpoint, so
yeah, for the midpoint, because the thing is going to pass through M. What was the midpoint?
We got 2 over 2 and minus 1 over 2.
Okay, so which was what? 1 and negative half?
Yes, sir.
Okay.
Yes.
Why am I writing this? Because we're going to need this point now. Remember, the line is parallel to BC. So what it means is that the gradient of that line there, because it's parallel, it's going to be negative 5 over 3. Okay. So that means the gradient of that line will be negative 5 over 3. Okay. Right. Now we're going to use our, okay, there's 2 ways to do it. You can use, okay, let me just go back. You can use the y equal to mx, or you can use that formula. There's 2 ways to do it. Okay. So let's use this. So y equal to mx plus c, since that's what you suggested. Okay, so that means y equal to, we know what m is. It's negative 5 over 3 times x. Now it's the c that I need to find. Now how am I going to find it? Well, this is when you're going to sub this point here, m. 1 and negative half. Basically meaning where there's x, you're going to replace with 1. Where there's y, you're going to replace with negative half. So it's going to be negative half is equal to negative 5 over 3 by x, which is positive 1, plus c. And then negative half equal to negative 5 over 3 plus c. So all you're just going to do now is take the 5 over 3 over. So that means negative half plus 5 over 3, because remember I took it over, is equal to c. And then, well, fractions, just use a calculator. Okay, so c is equal to 7 over 6. Okay, there. So what that means is that our final equation, therefore, is y is equal to negative 5 over 3x plus 7 over 6. You can actually leave it like that. It's not an issue really. Yeah. So What question are we doing? The length of
The
AB.
length of AB.
Okay, so we're going to use the distance formula,
formula.
right? Okay, so the length of AB, so there is AB, so we're going to use the distance formula. All right, let's do that. Okay, so what it means is that AB is equal to okay. You don't know the coordinates. Right, so that's the square root of, remember it's x1 minus x2, so x1 now we can take 3 minus x2, which is negative 4 there. Alright, square that thing plus y1, okay, so I'm going to take 5 there, minus y2, that's a negative 1 there, and then I'm going to square that whole thing, and that whole thing is under a square root. Yeah, this is just going to do in a calculator.
So it's just the root of 13.
Square root of 13. It's always better for you to just leave it as a third. It's much better for you to do it like that. Okay, let's see, what is the next question now? Oh, the inclination.
What is inclination now?
Right, inclination of AC. It's this line. So this angle, the theta that they gave here, that's the angle we're supposed to find. Don't you have the gradient of AC?
Yeah.
You don't have it. So you need to calculate that gradient. Okay. So we need to calculate the gradient of AC, which is equal to what? Y2 minus y1. So that's 5 minus negative 6 over 3 minus negative 1. This you can just also do straight away in your calculator.
11 over 4.
11 over 4. Okay. Now for me to find that angle theta, that one, obviously now for me to find theta, I'm just going to take the tan inverse. Remember tan of theta is equal to the gradient. So I'm just going to take the tan inverse of 11 over 4. So just do that with the calculator. Reduce it to 2 decimal places. Remember the default is 2 decimal places.
70,02.
70,02 degrees. Okay, so that's the size of theta. So that is how it's done.